So, Craig, the first thing I want to start off with here is you are, of course, you're the founder and the CEO of GMG. But what prompted you 6 or so years ago to start this company?
Yeah, look, that's something that a lot of people have asked because I left a pretty comfortable corporate role in Shell, and there was a bunch of others who eventually joined from Shell as well. And it's really seeking to find something that has an impact on the world that you could see could, I guess, create the demand or the outcome that you believe was there. And then bring it to the world so that you could create that change that you wanted to see. And what's funny is we're now getting more and more people from these very large companies who want to do the same, and they're saying the same things in the interviews for job applications. I think it's a real point to note that there are a lot of people out there in providing energy right now in its current form, and they see the problems that we all see, and they want to be a part of the change. And I think that was probably what really drove me back 6 years ago to do that. And now, we're lucky enough and hard work enough and a lot of really, hopefully, good decisions that got to a point where we can create that change at some kind of reasonable level of impact,
Yeah.
and then bring more people on to do that. So certainly very excited about where we're at and about what we can do in creating basically a nanomaterial carbon production clean tech company that will reduce emissions and create amazing energy storage systems.
Right. So, obviously the name Graphene Manufacturing Group, it's a little bit self-explanatory, but in any case, describe to us the company and what you guys do.
Yeah, so we take natural gas and we take it through a continuous process that we have developed ourselves, and we split the carbon atoms out from the natural gas, and we leave hydrogen. And then we take that graphene that we've made, which is the carbon atoms, and we put that into different types of applications. So currently we're focusing on three products, and then we look to sell those products into the market. So the three products we have are an air conditioning coating system or heat exchange coating system, which saves energy in the use of graphene. That's put onto various different types of heat exchangers and air conditioning systems and such things to save emissions and save energy. And then the second type of product is the graphene lubricant concentrate, which we basically make in a concentrate form and we sell to lubricant blenders in different parts of the world. And that's in slightly less developed point compared to our air conditioning coating system. And the third product, which is what most people want to talk to us about, is our new next generation battery, which is a graphene aluminium ion battery, which is very much multi-stage development progress past where kind of lithium batteries are right now. And that is a product that we make all those three products, some with some contractors. But the battery space, we've just announced our pilot plant, and we're progressing through into making another type of battery, which is called a pouch pack battery. And so it's very exciting. So we've really transformed from making graphene some 5 years ago to now making these ready-made products that people can buy and use our graphene and use all the wondrous forms that and the parameters that graphene has to bolt into their existing products or bolt into their existing businesses and use straight away.
So you mentioned the three products and the fact that most people, and myself included, want to talk to you about the latter, right? But can you give us a quick breakdown of the business, maybe in terms of like of revenue? I mean, where does the EV graphene battery fit into that equation?
Yeah, so where we're at right now is, we've got Thermal XR, which is our energy saving coating system. That's just starting to get some revenue, and we've been out in the market for that for probably 6 to 12 months in some kind of serious form. And we're now trying to get into some significant revenue, and we have projects happening in Dubai, Singapore, Australia, and we're just opening up America or North America. And it's a very prospective opportunity. We're pretty much the only company that makes this product, so we're creating that market demand as well as creating the supply chain and all of the technology that goes around selling that product and making people aware how it works. So that's that focus there. Where it comes to the batteries, though, that's where very large electric vehicle companies have come to talk to us about how we could use our graphene aluminium ion batteries in those. It's a super fast charging battery, available for thousands of cycles, highly recyclable, uses only carbon or graphene and aluminium. There's no copper, lithium, manganese, cobalt, iron, phosphate. It's just graphene and aluminium. So it's a low cost, highly available material source battery, which also operates as a supercapacitor. So it provides many things that currently the lithium battery, which obviously is the main technology out of play and is needed to get to where we need to for this transition to occur as fast as we can. So we have a number of different types of vehicle manufacturers who are wanting to talk to us about this. But of course, we're only 1 year into the development cycle of it, and
Sure.
we're really looking at how to accelerate that with these development partners and bring this to market faster with these large EV companies,
Right.
and those are conversations we're having right now.
Would you say though that that's where you intend the future of the business to be?
Yeah, I think it has a natural home. We have the ability to have basically no cooling. We have the ability to have a very high amps discharge, a very high power. We have the ability to be, in the end, much higher energy density than lithium. We have 3 electrons, so basically we have 3 times the energy density potential than lithium. So the potential to get up to 1,000 watt hours per liter or watt hours per kilogram is there. We've just got to do the work, and then we've then got the ability to do all sorts of various different types of technology changes that will come with our battery because it has such high power density,
Right.
up to 7,000 watts per kilogram, that you could in fact have a distributed battery system. You could design the car the way you wanted it and then put the battery where you wanted it. You could go back to those type of ideals, whereas right now the lithium battery really has dominated the vehicle design, and it's taken over where the cooling system is, how you store the batteries for fire and other different types of mechanisms or safety issues. And then you've also got to manage the type of motor system that you have to limit the current draw on lithium. So there's a number of things that you currently have inbuilt into EVs, which are actually fundamentally around the lithium chemistry. And when you come along with an aluminium ion battery, which is effectively no fire risk, no cooling required, it has massive power availability, very good energy density, possibly in the end much better than where lithium is. It has the potential to rethink an EV car to make it even
Sure.
simpler and lower cost.
Sure. So then let's ask the obvious question: why hasn't anyone done that?
Well, right now we're sitting at the highest energy density of any aluminium ion battery company or even science stated globally. So if anyone can do it right now, it's probably us, and it takes time to bring a new technology to market. We're sitting about 150 watt hours per kilogram, but that's likely without cooling. And when you include cooling for lithium, you're probably back to about 140 watt hours per kilogram if you just look at a Tesla S. So we're at or about where lithium is, but we've only put 6 months worth of work into developing this battery where it is now. So that's where we are. Lithium batteries had 30 years of scaling. We can use all the technology that the manufacturers are using for lithium. We can use all that same technology to manufacture the product, but we just have different chemistry, nanochemistry. It's fundamentally based on graphene, and it has, as I said, 3 times more electrons. So in the end, it has the potential to be a complete game changer. And I think there are some very large companies out there who realize that, and that's why they're talking to us. You have manganese, which is 2 electrons, so you have the potential there, but it's only still 2 electrons. So the energy density is still not going to be as good as aluminium. Aluminium is the most abundant material out there, apart from carbon. So you put together and it's highly recyclable. So it has many supply chain issues, which I think lithium batteries are just going to go see more and more of as we try to scale with all the constraints we have right now and geopolitical issues.
So what is your pitch then to the automakers? Use this battery. Use this kind of battery.
So we're ultimately designing a product that can be swapped out with lithium-ion batteries. That's what we're designing. So you don't need to take our tech right now. Eventually, you could even get it designed so someone can drive in their car and swap their batteries out for ours. That's where we want. That's years away, but that is a potential. We expect to be able to have that ability and grandfather all of the lithium-ion technology, kind of electronics, so that we can come in and help out. Because right now we need every damn solution we possibly can get to market to create this transition. So we want to add to lithium-ion battery value chain optionality and bring our market as much as possible. So how we're trying to do that is we're putting together the coalition of the willing. When you launch a new chemistry technology for batteries, it's not easy, as I was saying. So we have we've joined with Bosch to work on our manufacturing of our cells in the downstream. We've joined with Wood, who's a very large engineering company, for our graphene manufacturing process to scale that. We're talking to large material manufacturers for aluminium supply and working with them on that. And then, we hope eventually, once we put that in place, we eventually hope to put together, a large customer who can take us forward in both how the battery's used and then obviously grow the product into sales that can support a much larger scale impact that we're actually after. That's what we're trying for. So, those are the steps forward. In the meantime, we've got an enormous number of levers to pull. It's very, very low-hanging fruit for our battery tech. Early days, lots and lots of opportunity. We're already at the world state highest energy density and power density for this battery. I think it's the only hybrid energy battery, supercapacitor type battery available. And so now we've got to bring it to market as fast as we can.
Yeah, and speaking of that best case scenario, what is the timeline here?
Yeah, so we aim normally when you bring a new tech to market like this, you try to punch out coin cells to understand how it works. So that's what we're doing first.
Okay.
We have many different small appliance uses for this, and so that's the first thing we're doing. And so you might actually see it in your car, your car key. So our coin cells would be rechargeable in about 5 seconds. And you would have them working for 3,000 cycles, so basically forever, in a space where you would, maybe have to recharge them maybe every 6 months.
Yeah.
And then people can get the idea of how it works and people understand what we can do. And then we can then go to some kind of pouch pack, which would then provide probably personal electronics, which would provide people to be able to charge their phone in about a minute and still last as long. And so when you get to EVs, the real problem here, Spencer, is the vehicle will no longer be the constraint on charging. The infrastructure will be the glaring problem. And we will need twice as many batteries to charge these things if we have our battery in an EV next year, or thereafter, because you'll need a battery to store up the charge before you take it into the car. And that's going to be the challenge. So, I think our batteries the infrastructure is just not ready for a really fast charging, really fast charging, in mass anyway. But that'll develop because everybody's trying to push that along. And in the meantime, we'll work with some hopefully some really large global brands who can bring this to market, and provide that ability to use some really fast charging batteries at with pretty much no cooling and very high performance, and then recyclable at the end of the day. And so that's our focus. So we're both talking about near term, mid-term, and then longer term, where we're talking, sizable kind of gigafactory type conversations. But those are obviously, much later.
Yeah. Craig Nicol is the founder and the CEO of Graphene Manufacturing Group, trades on the Toronto Venture Exchange and in the U.S. on the OTC markets. Craig, a pleasure. Thank you so much for joining our list makers today.
Thank you, Spencer. Really enjoyed it.